Hello and welcome to this lesson for Grade 9 Design and Technology. Our last lesson was on pneumatics and today we will talk about hydraulics. In this video, you will have a look at the working principle of hydraulic systems, the benefits and limitations of hydraulic systems, and the common applications of hydraulic systems. Hydraulic systems generate, transmit, and control energy or motion by applying pressure on a confined fluid or liquid using a pump. Why do we use a fluid? Firstly, fluids cannot be compressed. Secondly, fluids have the ability to multiply force. The most frequently used fluid is oil. The use of oil is due to its lubricating and anti-corrosion properties. A hydraulic system consists of the following elements: an oil reservoir used to store oil, a hydraulic pump used to pressurize oil, control valves used to control the speed and direction of oil, output components, a piston and cylinder used to produce a linear movement, hydraulic motor used to provide rotary motion, pipes or tubing used to transmit pressurized oil, hydraulic fluid to transmit power and lubricate the system. Note, hydraulic systems work in a closed circuit as fluid cannot be released in the environment in the same way as air for pneumatic systems. This is a schematic diagram of a simple hydraulic system. The oil reservoir contains oil, which is pumped through a pipe and a control valve to a piston and cylinder. The oil in the cylinder is pressurized and causes the piston to move. Let us use a car jack to illustrate the working principle of a hydraulic system. When piston 1 is pulled up, check valve A opens, check valve B remains closed, and oil from the storage tank flows to the pump. When piston 1 is pressed down, the check valve A closes, preventing oil to flow to the tank, but opens valve B, allowing the flow of oil in the hydraulic cylinder, resulting in an upward movement of piston 2. Successive upward and downward movement of piston 1 causes piston 2 to rise to the desired height. Opening the directional valve allows oil from the hydraulic cylinder to flow back to the storage tank, resulting in a downward movement of piston 2. We have benefits and limitations of hydraulic systems. The benefits are: transmission of large forces is possible using small components. Hydraulic systems can start up under heavy loads. They have even and smooth movements independent of load. They offer precise positioning. And all moving parts are constantly lubricated by the hydraulic oil. The limitations are that they can cause damage to the environment due to leakage of hydraulic fluid or if fluid is not disposed of properly. They are difficult to adapt to small machineries due to structural weight and size of the hydraulic systems. Impurities found in hydraulic fluid can cause considerable damage to the whole system. They have high initial cost. Common uses of hydraulic systems are hydraulic lifts and elevating platforms, hydraulic brakes in vehicles, hydraulic shock absorbers, applications in heavy equipment, for example forklifts, cranes and bulldozers, hydraulic jacks, presses, and injection molding machines. Having gone through the previous explanations, work out the answers to these exercises. Briefly define the term hydraulic. List the main components of hydraulic systems. List 3 benefits and limitations of hydraulic systems. State 3 common applications of hydraulic systems. In this video, you had a look at the working principle of hydraulic systems, the benefits and limitations of hydraulic systems, and common applications of hydraulic systems. This brings us to the end of this presentation, and do remember that all our videos are available on the website of the Ministry of Education under the Student Support Program. Thank you for having watched this program, and do catch us for our next lesson for grade 9. Goodbye.